Let's continue our journey in Chapter 10, dealing with probability. Taking a look at 10.5 today, talking about permutation and combinations. And maybe in your calculator, you've seen the button where you have like NPR and NCR. And so we'll be using those keys on your calculator in order to help us solve out different probabilities. The first type that we'll look at right here happens to be that of a permutation. And specifically, a permutation is an arrangement of objects in which order is important. So one of the key things to realize when solving a problem that's permutation or figuring out if the question happens to be a permutation problem is there is talk of order or arranging your um, your items. In our chapter or in this section, a lot of the questions talk about like arranging letters. Okay, so that would be a type of a permutation. So once again, and I put it here in red again, is that items described must be put in order. So that's the first type. We also have this another key item right here, which happens to be combination. All right. And that is a selection of objects in where order is not important. Okay, so those are the two key concepts that we're going to be learning in this lesson. Permutation, combination. One, order is important. In the second, the order is not. And not to be forgotten right here, in between the two, we talk about n factorial. And the factorial is a product of integers from 1 to n. Okay, so if you take a product of, let's say we start with 1 and we go all the way to 5, you take 1 times 2 times 3 times 4 times 5. All right, so it's a number counting system that we also have, and that is factorial. On your calculator, you may have noticed that there is an exclamation mark. And that exclamation mark is not a punctuation like you would in English, but it is to represent factorial. So if you type into your calculator 10 factorial or 10 exclamation mark, what your calculator will end up doing is take 10 times 9 times 8 times 7 times 6 times 4 times 3 times 4 times 1, and it'll multiply all of those together to get you that number that it'll pop out. One thing to, I guess, note and to memorize is that if you take 0 factorial, that actually equals 1. Okay? So one of those little key little fun facts for you to memorize. Now, in Algebra 2, there is some talk of this binomial theorem. Okay, when you're in geometry, you're not going to see this term binomial theorem. And what exactly is the binomial theorem? You can use to find the coefficients of a binomial expansion. Okay, so if you recall, for those of you in Algebra 2, in chapter, I believe it was like 4.2, okay, where we dealt with Pascal's triangle. And we mentioned we have a plus b, this binomial, raised to the n power. And we had to expand that out. And then we talked about, with the help of Pascal's triangle, how is it that, or what the coefficients are. Right, so if it was like a plus b to the 5th power, hey, we knew that, hey, we had a certain amount of terms, and then how we found the coefficients there. Well, with the binomial theorem, it's another way of finding the different combinations to help you come up with that, the coefficients, but we're not going to talk about that so much in this section in either. I'm just kind of briefly touching upon it to help you kind of make a connection with what we did in 4.2. I guess another thing, to go back to our term combination, once again, I mentioned that, look, it is a selection of objects where order is not important. Some of the problems in the book could talk about like is like drawing for 3 identical prizes. Okay, so let's say we have first, second, and third, or there's 3 prizes. They're all the same. Uh, Remember, order doesn't matter. It doesn't matter if you're first, second, or third place. Uh, you could say top 3 finishers get a prize, and it happens to be the same prize. So that would be dealing with combination. Uh, but let's say it did matter. Like we had 3 different prizes, and we had first, second, third for each person. What could end up happening right there, that we use permutation because of the fact that um, a prize is given for each and every place. So that's when the differences of using permutation and combination. So let's take a look at this core concept and the equation that you are going to be using. The first one right here for permutation, and the formula is n, like subscript n, p, and then n. And so this right here represents n factorial. Now, when do we use this? Well, what do they mean by n and n? The number of permutations of n objects, if they happen to be the same. So if you look right here, see how the subscript 4 and the subscript 4 after the p, it's the same. So if that's the case, what does that mean? It's going to be that number, whatever n happens to be, factorial. And so when I mentioned earlier, factorial is taking a number and multiplying each and every integer from 1 all the way up to that number. So right here for this instance, you take 4 times 3 times 2 times 1, you multiply it together, and that is 4 factorial, which happens to be 24. If you use your calculator or use Desmos right here, it will, once again, it will do that for you. Right, so if we take a look at this calculator on Desmos, you can see down right here at the bottom, there is this exclamation mark. So if I went ahead and I put 4, and you have to go to function, press the exclamation mark, you will see right there, it now equals 24. We also have NPR and NCR, and then I'll show you how you can use that in a bit. Going down to the next section, well, what happens when n and then we have another variable r? They happen to be different. Okay, we talk about the number of permutations of n objects taken r at a time. Okay, so let's say you have like 10 letters, and you're going to take 2 at a time. And it's going to talk about, well, what are the different permutations in that instance? And then it's important where r needs to be less than or equal to n in order for you to use this equation. And it's pretty simple. As long as you know where n and r is, and then you go ahead and take this equation right here and make sure you memorize it. Okay? Use it and memorize it. There you go. Just that simple. If you pay attention right here to our example 4, and then take a look, that's what n happens to be. And I'm highlighting where n is. We have next up, we have r, which is 2, and that goes into the equation where there happens to be 2. If you were to do this by hand, okay, and you may have to, depending on the question, you know, what you end up doing right here is you take 4 factorial, and so you take 4 times 3 times 2 times 1. And then you go ahead and take, you got your 4 minus 2 factorial. So 4 minus 2 ends up getting you 2. And then if we take the factorial, it's 4 times 1, right? So let me go ahead in my numerator. Let me go ahead and rewrite that. And what ends up happening here is that, hey, we can go ahead and cancel things out. And so what you're left with is 4 and 3. And you take 4 times 3 and you get your answer of 12. Okay, so fortunately, you have your calculator. You'll be able to get your same answer. Now, how will the calculator end up working? Okay, so if you press, and we're taking a permutation, you press the NPR, and then you now have parentheses. Well, what you end up doing is, remember, we need to figure out what is N and what is R. And so what you happen to need to do next is you will go ahead and type in the first number. That will represent N. So we'll put 4 right here, and then you have to put R next. In order for you to do that, you're going to press this comma button, and then go ahead and punch in what happens to be R. And let's go ahead and put in 2. We'll close the parentheses, and as you can see right there, it gave me the answer 12. Okay, and that's simply how you would use NPR, your permutation and combination, on your scientific calculator. All right, let's go ahead and move on and take a look at combination. Okay, so a combination is a number of combinations of n objects taken r at a time, where once again r is less than or equal to n. Okay, and right here, the equation is a little more complicated. And let me go ahead and put this right here and make sure you put memorize. Okay, we want to memorize that. And so you can see it ends up being n factorial divided by n minus r, parentheses factorial, times r factorial. So there is a little bit more work right here, a little bit more to memorize, and spots for you to plug in your r and n, or n and r, in order for you to get your answer. Okay. One of the key differences, and I put down right here, is between combination and permutation. One is order, but what makes combination its own unique self is that combination crosses out duplicate possibilities because order is not important. All right, so that's another key thing right here. I think that you will need to know to help you memorize the difference between the two. All right, so let's take a look right here at number 1. Let's go to our exercises. So in extra practice 1, it says in exercise 1 and 2, find the number of ways you can arrange A, all of the numbers, and B, 3 of the numbers in the given amount. Okay, so right here, the question is, all right, so is this a permutation or a combination problem? Does the order matter? And you have to sometimes read the question very carefully, maybe read it over. Are there any key words that come about? And I'll say right here, this word arrange, because that arrange right here will tell me that we are dealing with a permutation. Okay, so you got to think, what are arranging? There's an order to some of this. So therefore, we have a permutation. And it says find number of ways you could arrange all the numbers. Okay, so if you're going to arrange all the numbers right here, I got to think, well, what is n and what is r? How many numbers are there? There's a total of 7. Okay, so what I'm going to do is go ahead and put 7. We're dealing with a permutation, and we says, well, if we're going to arrange all the numbers, that means we're going to arrange a total of 7 numbers. So that's what we have right here, 7p7. All right, so this one's a little tricky, right? The first problem, they try to tell you, all right, first off, remember, think about how many numbers do we have, how many objects, and how many will be taken at each and every time. And so we're going to arrange all 7 of them. So therefore, if we were to write this and do this by hand, I'd have 7 factorial over 7 minus 7 factorial. And all of this right here ends up equaling, we have 5,040. So there's 5,040 different ways for us to arrange all the numbers. Okay, let's go move to part 2. in part 2, things are a little bit different because it says 3 of the numbers in the given amount. So remember, to start off with, we have, all right, we have n, and that's the number of objects that we have. So we still have 7 numbers. We're dealing with the same figure, that 2 million figure. Still a permutation because we're dealing with order. But this time it says we're trying to pull 3 of the numbers of the given amount. So there you have it right there, 7p3. And so if we go ahead and plug all things in, we have 7 factorial. And then right here I've got 7 minus 3 factorial, and get your answer. So when you put all this together, there's only 210 different ways that we can arrange those 7 numbers, given the fact that we are going to use 3 of the numbers in the given amount. Next up, let's go ahead and take a look at problem number 3. It says your rock band has 9 songs recorded, but you only want to put 5 of them on your demo CD. So there's some numbers right here that stand out, 9 and 5. And then to hand out, find them on your demo CD to hand out to local radio stations. So now it says, how many possible ways could the 5 songs be ordered on your demo CD? Once again, remember, you want to try to figure out what is important here. Is it a permutation or a combination? And so keywords like this right here, ordered, tells me, hey, that this right here happens to be a permutation question, right? The order does matter. So you have to think, well, how many different items do we have, or objects? This one being songs. We've got a total of 9 songs. We have a permutation, and then right here, you go ahead and how many do we want? We want 5. Okay, so if that's the case, let's figure out what we can do here. Remember, so the equation is going to be n factorial, so 9 factorial divided by 9 minus 5 factorial. And so if you go ahead and use your calculator carefully, or maybe even use that permutation button, you will end up with a grand total of 15,120 possible ways you could order the 5 songs on the demo CD. Quite a bit there, huh? Next up, let's go to problem number 4. Okay, we have right here the witness at the scene of a hit-and-run accident saw that the car that caused the accident had a license plate with only the letters I, R, L, T, O, and A. And it says find the probability that license plate starts with a T and ends with an R. So let's figure out, is this a combination or a permutation question? Does the order happen to actually matter? And I think it's easy for us to say that, look, if the license plate starts with a T and ends with an R, that deals with order. So that makes this a permutation type problem. All right, so now, if it's permutation, well, how many items do we have? That's where we figure out how many letters we have in total. And so we have ourselves 1, 2, 3, 4, 5, 6 total letters, right? It's a permutation, and remember, we have ourselves 2 key letters that we're going to be dealing with right here in the order. And let's go ahead and we'll put 2 down right there for R. So if that is the case, now we can go ahead, use our trusty calculator, but I'll go ahead and write this out for you. We got 6 factorial over 6 minus 2 factorial. So if you go ahead and put all that together, you will end up with the number 30. Okay, so there are 30 different ways of finding or having getting the license plate based off of our information. Now, what makes this problem a little bit different right here than the others is that they're saying, well, what is the probability that the license plate starts with a T and ends with an R? Well, there's only going to be one correct one, right? So if there's 30 different ones, but there's only going to be one correct set of numbers or plate letters, then what that tells me, we got to treat this as though it is a ratio, and that ratio would end up being 1 out of 30. And this right here would be our answer. That is the probability that the license plate starts with a T and ends with the R and has those letters exactly or in the order of finding that exact license plate. All right, so there is 1 out of 30 chance right there. You think, well, how many favorable outcomes do we have? If we were only looking for that one person, that one car that happens to have that exact license plate, 1 out of the 30 possible different ones. Okay. And then finally, let's take a look at number 5 right here. How many possible combinations of 3 colors can be chosen from the 7 colors of the rainbow? So we have, this time, remember, we have NCR, right? We have the total number of items here, objects, 7 colors of the rainbow, and we've got, it even tells you its combination, so we have 3 colors. So let me go ahead and write this. We got 7, combination of 3. And let's go ahead and write this out right here. So we got n factorial, so it's going to be 7 factorial divided by, and then we have ourselves n minus r factorial, and then times 3 factorial. Okay. So if you go ahead and simplify that or plug it into your calculator, you should end up right here with 35. So how many possible combinations are there? There are 35. And we go back to our calculator. We trying to show you how to do this. On Desmos, you go to function. We got NCR. We plug in n first. I'll use the comma, and then we'll plug in 3 seconds right here, and you end up with that same number that I just gave you, 35. All right, so there you have it. We now deal with permutations and combinations in this section. All right, so go ahead. Thank you for watching. Go ahead and please like and subscribe. Greatly appreciate it, especially if I helped you out today. All right, have yourselves a great one, and I'll see you again.